Dear colleagues, dear grid participants, I will present you a work titled Thermostability of Packaging Papers Treated of Silver Water. The application of nanotechnology shows significant advantages for improving the quality of packaging materials. Innovation related to the use of nanotechnology in food packaging and quality control is the focus in the modern food industry. The silver nanoparticles can be relatively uniform distributed in a matrix of other materials such as pulp, plastic, and others, and thus be more effective at killing bacteria and fungi either in stock preparation or as a coating. Packaging materials with nanoparticles of silver or silver-containing coatings allow creating effective and safe antimicrobial packaging. Therefore, studies on the thermostability of the silver water-treated cellulose paper and packaging could possess the desired knowledge if the silver water treatment catalyzes the paper aging or makes it more stable. This research shows the preparation, characterization, TGA, and accelerated thermal aging analysis of packaging papers treated with silver water. The purpose of the research conducted was also to improve the antimicrobial activity of the produced papers, which was also achieved, and results are in process of publication. As a raw material for the paper samples production was used a mixture of softwood and hardwood cellulose in ratio 80 to 20%. Wet and chemical additives have been added to obtain base paper in the following sequence: AKD as a sizing agent and modified cationic retention additive. The obtained base papers has been sprayed with an exact amount of silver water with concentration of 10 milligrams per liter. The main methods used in this work were defining the type of the cellulose used with a microscopic analysis, grammage, thickness, density, porosity, and smoothness determination, tensile strength, tear index, elongation, and tear resistance, TGA analysis, and color coordinates in each 6 hours during the 72 hours of thermal aging of the obtained paper samples. As a result, from the fiber characterization with a microscopic analysis was observed that the bleached sulfate softwood pulp is from pine wood and the bleached sulfate hardwood pulp is from beech wood. From the data on the structure of dimensional properties of the base paper and the silver water treated papers, it is found out that the addition of sizing agent and retention additive does not affect the smoothness of the paper. Regarding the samples treated with silver water, an increase in the smoothness of the paper was observed, and as the amount of the silver water increased, the effect decreased. As expected, the thickness of the samples had mostly the same values, with a slight decrease at paper samples treated with 2 and 3 milliliters silver water. These results are based on the additional moistening of the paper as silver water solution and their subsequent drying on the sheet making machine at 96 degrees Celsius for 5 minutes. During this additional drying process, the effect of the temperature and the pressure on the machine have the effect of calendaring onto paper, which is also confirmed by the data on the density and porosity indicators of the investigated papers. From the data in the table, it can be seen also that the amount of silver water increases from 1 to 3 milliliters the density increases and the porosity decreases. The main purpose of silver water treatment is to achieve antibacterial activity in order to obtain a special type of paper with application in packaging production in important sectors such as household, food, packaging, medical and pharmaceutical products. As the consumption of the silver water increases from 1 to 3 milliliters, the values of the strength indicators, although within the error of the analysis, decreases. This effect is due to the irreversible destruction of the already formed hydrogen bonds between the cellulose fibers in the paper base, and the subsequent drying after spraying with silver water cannot compensate from the loss of the initially formed hydrogen bonds. Therefore, any additional processing of the paper should be carried out before the complete drying of the paper web, and if it cannot be avoided, the decrease in the strength indicators of the paper should be foreseen. In additional paper production, this reduction could be prevented. The results from the TGA analysis shows that all samples have 3 stages of weight loss. The less the amount of silver water was in the sample, the highest weight loss was detected. When comparing the weight losses of treated samples examined, it was found out that 2 milliliters of silver water increased the burn-up temperature of the paper by approximately 15 degrees Celsius. The pattern of the thermal destruction of the investigated samples is not different. Undoubtedly makes an impression. The different behavior of the sample with 3 milliliters of silver water, which burns faster and is characterized with weight loss of 25% in the range of 375 degrees Celsius. The color coordinate L, which expresses the lightness, brightness and the brilliance of the paper, decreases with the silver water treatment. The color parameter variation with the time is comparatively low, being most sensitive during the first 24 hours of aging. With increasing the consumption of the silver water and the duration of the thermal aging, the color of the paper samples is getting darker and the color difference is getting bigger. At 3 milliliter silver water treatment, the lightness of the paper samples significantly decrease. From the color coordinates measurements presented in this slide, it is clearly visible that the cellulose and base paper are most stable and there is no drastically amending of the color. For the other 3 examined paper samples treated with 1, 2 and 3 milliliter silver water, the color amending occur after the 36 hours of aging. The values of the color parameter decreases, which means that the paper is getting darker and yellowish. The change is significant and with a large step of the paper sample treated with 3 milliliters of silver water. Therefore, colloidal silver on the paper surface accelerates the aging and catalyzes the oxidation and hydrolysis of cellulose fibers. This is also confirmed by the observed decrease in the strength indicators, evidencing the destruction of hydrogen bonds between the cellulose fibers in the paper. From the research conducted, it might be concluded that coating and surface treatment of paper with multifunctional chemicals or additives has been proven excellent methods for improving its properties and for achieving the spectrum of its application. From the research carried out with paper samples of bleached softwood and hardwood pulp, treated with silver water, was found out that treated papers has excellent thermostability, as the color coordinates do not change significantly during 72 hours of accelerated thermal aging. Research has also shown that it is not recommended to be used more than 2 milliliters of silver water, as silver ions catalyze the aging process and the paper darkens and turns yellow in a greater degree. The changes of the weight of the paper samples as a function of temperature was mentioned by TGA. When comparing the weight loss, it was found out that for the paper samples treated with 2 milliliters of silver water, the temperature of complete burning of the sample increased by 2.28 degrees Celsius. It moreover makes an impression the different behavior of the sample with 3 milliliters of silver water, which burns faster and is characterized with weight of 25% in the range of 375 degrees Celsius. In addition, the surface of the treated paper samples is more even compared to the untreated due to the glandering effect of the manufacturing process. We would like to gratefully acknowledge the financial support of Scientific Research Fund Bulgaria, University of Chemical Technology and Metallurgy, Sofia, Bulgaria, and University of Ljubljana, Slovenia, Faculty of Natural Science and Engineering. If you have any questions, please do not hesitate to contact me. Thank you for your attention.